Good morning, students. Today we are going to discuss some JEE previous paper questions. First question I will deal with. Look at this. The equivalent mass of H3BO3 in its reaction with NaOH to form Na2B4O7. So what they are saying, they are asking to calculate the equivalent mass. We have to know the reaction in equivalent mass. Otherwise, we have to know the oxidation state. For example, equivalent mass will be equal to molecular mass divided by n factor. How we can find out that n factor? N factor is nothing but for acid. Actually, H3BO3 is an acid. For acid, it will be number of replaceable H plus ion. So, number of replaceable H plus ion, or n factor for base will be number of replaceable OH minus ion. But here this is not a base. The structure of a boric acid will be like this. But OH is not at all attached with the metal atom. Boron is a non-metal. That is why OH can behave only like acid. It will not be donated as OH minus. In NaOH, OH minus will be donated in water. But here it could not be possible because boron is a non-metal. When OH attached with the non-metal, it can behave like an acid. That is, OH cannot be released, but instead H plus can be released. So number of replaceable OH minus for base. But here we are having acid. So number of replaceable H plus ion we have to determine. But here it is not possible to donate H plus ion in the case of boric acid because it is a Lewis acid. Lewis acid means it will accept a pair of electrons. So Lewis acid, according to Lewis concept, acid can accept the pair of electrons. So usually boric acid will act as an acid by accepting a pair of electrons. It's not like Arrhenius acid. Arrhenius acid means it should donate proton. But here what will happen? OH minus will be accepted. That is, OH minus means electron pair with OH minus will be accepted by boron. That is why we can call that as Lewis acid. So in that Lewis concept, the number of vacant orbital determines, or the number of electron per acceptance determines the n factor. Here the n factor will be 1. Why? Because only one electron pair has been accepted. That is why n factor will be 1 in case of boric acid. Let us find out whether I am having another one doubt, because for redox reaction we are having another one n factor definition, that is number of electron transferred per molecule. N factor will be number of electron transferred per molecule. So I'm having doubt on that because boric acid, I know the oxidation state of boric acid will be, that is H3BO3 has been converted into Na2B4O7. Then we should determine the oxidation state of boron. Here X plus 3 minus 6 overall 0. So X is equal to plus 3. Here the oxidation state of boron will be plus 3. And here we are going to find out that 4X and then Na2B4O7, that is Na2 will be 2 and minus 14, overall it will be 0, then 4x will be 12, then again I am getting x is equal to plus 3. So the oxidation state change is not there, so not necessary to use this one, that is number of electron transferred per molecule cannot be used here because the oxidation state is not at all changed. So we have to go for acid base concept only, because this borax is a salt. Salt will be formed by neutralization reaction, or a displacement reaction. There will not be any change in the oxidation state. So displacement reaction means there will not be change in the oxidation state, that is mutual displacement reaction will be there. So for mutual displacement of acid and base, there will not be any change in the oxidation state. That is why we should not use this method. This is not a base, even though it is having OH. That is why we should not calculate n factor by number of replaceable OH, and we have to calculate number of replaceable H plus for acid. But here H plus is also cannot be donated, so you have to use the Lewis concept. So according to Lewis concept of an acid, number of, that is n factor will be number of electron pair accepted. So only one electron pair has been accepted here. Electron pair acceptance for Lewis acid. That is why only one electron pair has been accepted, means we have to go for n factor as 1. So n factor 1 means equivalent weight will be molecular weight of that boric acid divided by n factor 1. That is all. That is we are having that answer, M, right? Molecular weight alone. So capital M will be molarity. That's why I have said like that. Okay, anyway, we will go to the next question. This one will be somewhat tricky. The second question will be somewhat tricky, but first question, no issues. Here they are asking which of the following isotopes is more likely to be stable. So I'm taking SN. 50 is the atomic number, and 123 will be the mass number. So to find out the stability, what is the meaning for stability? Why we are checking the stability? Because when the atoms are having higher atomic mass, then there is a probability to form unstable isotopes. That is, nuclear reactions will be possible when the atom is having higher atomic mass. That is why we have to determine how many neutrons are there. You know about that neutron and proton ratio should be 1. That is, it should be equal, because to get the binding energy properly, we should have the neutron and proton energy. Sorry, neutron and proton energy should be 1. That is, number of protons and number of neutrons should be equal. Then it will be very stable. But anyway, if you are not getting that n, that is number of neutrons and number of protons are same, then you have to go for some other thing, that is number of protons by proton, the number of neutrons by number of protons ratio. If you are having one, no issue, stable. But if you are having more than one, n by p more than one, it is highly unstable. It will undergo nuclear reaction. That is why we have nuclear reaction is not at all a chemical reaction, it's a physical reaction. So nuclear reaction, I think you will learn in your 12th standard nuclei lesson. Anyway, I'm teaching that here also. It is not a reaction, it's very simple. So which type of atom can undergo nucleophilic substitution can be identified by the number of neutrons and number of protons ratio. So number of neutrons we have to determine. What is that number of neutrons? It is very easy. 123 minus 50. You know about that, I think, right? So proton will be 50. So 73 divided by 50 in the case of zinc, that is 10. That is why we will get 73 divided by 50 ratio. It is more than 1. Look at this. And then here, lead. Lead is having atomic mass 206, right? So 206 minus 80, number of neutrons will be 206 minus 82, and the proton will be 82. So 82, that is 18, 118. I think it is also going greater than 1 ratio, right? And then I'm going to check for BP. I think it will also be like that, because number of neutrons are very high, right? So tin, we have to go for tin. Again 50, 118, right? So 118 minus 50, then it will be 68. So 68 divided by 50, number of protons will be 68, that is number of neutrons, and protons will be like that, 68 divided by 50. So n by p ratio, if you are finding that, I think this one will have the lowest value. Here, let us check that. 68 divided by 50. 73 divided by 50 will not be there. That is, it will be greater, right? So I think we have to go for this option. Anyway, I will check that also. So n by p ratio for that, what is that? Sn, that is tin, with 118 atomic mass. That will be 68 divided by 50. So we are getting 1.36. Again, it is not a stable, but we have to go for higher stable one, right? So the ratio for this one will be 1.36. Again, the ratio for that plumbum, 206 minus 82. That is, so we are having 206 minus 82. I'm using the calculator, but please don't use the calculator. 124 divided by 82. 1.5. So it is 1.5 actually. The ratio for this one will be 1.5. High. It is, we are having the higher value of n by p ratio than SN 118 isotope. So this will be the answer. Hope you have understood that one. If you can't, you please send a message to me, to my WhatsApp number. Okay, and then we will go for this question. Under the same conditions, how many ml of 1 molar KOH and 0.5 molar H2SO4 respectively when mixed for a total volume 100 ml produced highest rise of temperature. So highest rise of temperature, how the temperature has been raised when you are adding the base and acid because of that neutralization reaction. You know about that when 1 mole of acid and 1 mole of base has been neutralized, it will form 1 mole of water. At that time it will release 56 kilojoule per mole. That is 56, almost it will be 57. So 57 kilojoule per mole has been released, but you should take 1 mole of H plus and 1 mole of OH minus. So neutralization will be maximum. That is neutralization will be maximum means there should not be any excess H plus, there should not be any excess OH minus. Then it is possible to attain the higher energy release. So higher energy release means it will increase the surrounding environment. If we are carrying out the acid base reaction in this compartment, it will release the energy to the environment. So the environment temperature will be increased. So that is why they have given highest rise in temperature. Okay, let us check that. Actually, I know the answer for this one. When seeing that itself, I couldn't able to get the answer, but you should not do that one. You have to try everything when you are going for the learning process. Learning process, you should not skip anything. Directly, you should not check the answer alone. You have to go for the first case. That is, we will use the first one. Uh, First, we know we have to get an idea about that the maximum neutralization reaction. That is, maximum neutralization will be possible by getting the stoichiometric reaction. So please have that stoichiometric reaction. KOH and then H2SO4. The salt formed will be K2SO4. That is why we should use 2 molecules of H2 will be released. We should use 2 moles of KOH. If you have taken the mole ratio as 2:1, then there will be a complete neutralization. That is why we need stoichiometric reaction. So if you are taking the same amount of KOH and H2SO4, then the neutralization will not be the maximum. The excess reagent will be there. So you should use the ratio according to the stoichiometric equation. So 2:1. Be very careful on this point. 2:1 will be there for maximum neutralization for KOH and H2SO4 acid base reaction. But in the case of NaOH and HCl, not necessary to go for 2:1 ratio. It will be 1:1 ratio according to the stoichiometric equation. Look at this. I will write for NaOH and HCl. HCl and NaOH means not necessary to take 2:1 ratio. It is 1:1 ratio will be enough for mole. But here, to get the maximum neutralization, we need 2:1 ratio. That is why we have to check whether they have taken the 2:1 ratio for this case or this case or this case. First, I am going to check with the 67 and 33. What they are saying, 67 ml they have taken KOH, and then 33 ml they have taken H2SO4. Let us check whether they have taken that same mole ratio. Then it will be possible to get the maximum neutralization. Okay, let us check that. Look at this. 1 molar KOH they have taken. So number of moles we have to identify. Then only we can compare that mole ratio. So number of moles, how can we get that from the molarity? Molarity will be equal to number of moles divided by volume of the solution in liter. Then number of moles will be molarity into volume. So molarity will be 1 into volume will be 67 into 10 to the power minus 3. So this is actually the number of moles for KOH case. Then according to the maximum neutralization concept, we should get the mole ratio like this: 67 into 10 to the power minus 3 divided by 2 only we should get. Because if it is 2, it should be half, right? Because it's 1, right? So 2:1. So if you are taking KOH 100%, you should take H2SO for 50%. So 67.3, 67 into 10 to the power minus 3 moles if you have taken, you should take 67 into 10 to the power minus 3 by 2 for maximum neutralization. But what they have taken only 33 ml. Let us check the number of moles here. So the actual amount, that is the exact amount that they have taken will be number of moles. That will be 0.5 into 33. That is 33 into 10 to the power minus 3. How I can write this one? 33 into 1 by 2 into 10 to the power minus 3. So this is not equal to 67 by into 10 to the power minus 3. That is why maximum neutralization will not be possible. So there will be an excess of KOH in this case, the first case. So we have to go for the second case. Let us check the second case. Again, the second case, they have taken 33 ml of KOH. So if we are having 33 ml, 1 molar, that is molarity into volume. Number of moles we can find out by molarity into volume, 1 molar, and 33 will be, that is first one will be 33. So 33 into 10 to the power minus 3. And here we have to take actual amount we have to take for maximum neutralization will be the half of that KOH. So KOH will be 2, H2SO4 will be 1, means we have to take half the amount of KOH amount. So 33 into 10 to the power minus 3 divided by 2 we should take, but what they have taken 67 ml. So the molarity of H2SO4 will be 0.5. 0.5 into 67 into 10 to the power minus 3. So how I can write that one? 67 divided by 2 into 10 to the power minus 3. That is also not at all possible for maximum neutralization. Originally, they should take this one, but they have taken this one according to the second choice. Then not necessary. You please do for C also. You will not get answer, but anyway, you please check that. While you are while you are checking the wrong answer, then it will be uh, you will be clear on that concept well. So please try the wrong choice also. Why this will not come? Why this will not come? Like that, if you have tried a lot, the concept will be clear more for you. Okay, then 50 is to 50. Let us check this one also. Okay, again, KOH should be 2 ratio and H2SO4 should be 1 ratio. This is mole ratio. So find out the mole with 50-50 volume. So number of moles for this case, 1 molarity and the 50 into 10 to the power minus 3. Why I have written 10 to the power minus 3? Because they have taken an ml. So molarity means number of moles divided by volume of the solution in liter. So ml I have converted that into liter. So this is the number of mole for KOH. And here for this one, we have to take 50 into 10 to the power minus 3 divided by 2 number of moles for H2SO4 for maximum neutralization. But what they have taken, let us check. So the number of moles will be calculated for H2SO4 will be 0.5 into 50. That is 50 into 10 to the power minus 3. So 0.5, how I can write that 0.5? 50 divided by 2 into 10 to the power minus 3. So D will be the right answer. Hope you have cleared about that concept. If you are having any doubt, you please send your doubts to my WhatsApp number. Thank you.